Very good evening to all of you. Welcome you guys. Welcome you guys. Good evening to all of you. Hope I think so. We are in live. So here all of you do comment it whether the class is live or not. First of all, I think we are in live. All of you do comment it. So first of all, you tell me now here whether am I audible or not? Is audio video is clear? Is my audio video is clear? Everybody? Right. Now I hope now today we don't have any problem at all. I hope today we don't have any problem at all. Yes. Now, fine. So let's start our discussions now here. That is a concept through questions. The concept through questions we are going to discuss now here. And in this series of classes, I'm planning to discuss nearly 400 problems on the transients I'm going to discuss. I'm going to discuss about the very basic level problems to the advanced level problems. So I hope you will get a lot of confidence in this after solving these many questions. Generally, students will face difficult in the transient topic, but I will try to make this topic is very simple for you all of you. Okay, so let's start our discussion, all of you, everybody. The concept to the questions, right? Next. So, and to join my Telegram channel, you can search in the Telegram group, that is B V Reddy GATE. You can search my name, there you can get my Telegram channel and you can join in this. Right. And Unacademy is providing a great opportunity to have a plus subscription, to experience a plus subscriptions. So here the Unacademy is providing the 7 days free trial. 7 days free trial is providing. So it's a very great opportunity to all of you. And this validity is from the 9th to 12th. That means today is the last day to avail these opportunities. And you can simply scan the QR code, register with your goal and activate. You can enter the code of BV Reddy. By using the code of BV Reddy, you can activate this offer and start learning. You can use a code of BV Reddy. All of you. Now I hope so here everything is visible properly. And so one more opportunity is if you are planning for this as an Unacademy subscriptions, a great opportunity is Unacademy is providing providing no cost EMI. With just EMI you can able to take the subscription without any additional charges. Right. And the advantage of this one-to-one live mentorships, with the 6 months you will get 12 sessions, 9 months 18 session, 12 months 24 session, 18 months 36, and 24 months 48 sessions you can avail it. And the special class features, now I'm taking the daily special classes. We have taken alternatively, we are planning the 1 day YouTube session, the other one we are planning the special classes. And the special classes I'm discussing the network theorems we are doing. In the special classes we are doing the network theorems, right? So if you can follow the network theorems, and that YouTube sessions I'm planning the transients I'm doing. And today is a first class on the transients. So theorems and transients we are doing, and the theorems in the Unacademy special classes and the transient topic in the YouTube sessions. Okay, I hope all of you can utilize these opportunities. And about my profile and all, the link given in the descriptions, you can see the link, you can able to attend the classes. And Unacademy is providing the daily scholarship. The top one ranker will get a 50% of the scholarship, and 30% for top 1 percentile and 15% scholarship, and the remaining fellows will get 10% of scholarship. You will get it. Next, practice all the PYQs with the Unacademy PYQ series. And about this community, so with the community you have a regular updates from the educators, notes, DPP, important questions are available, and exam tips and tricks and preparation talks and motivational messages. And by taking this Unacademy subscription, you can use this code here by using the code of BV Reddy. By using the code of BV Reddy, and you do avail this all the great opportunities. Fine, all of you will get maximum discount. You will get. And these are the new batches you are running. You can find the top educators of India. You can find here in the team, and these are the top educator teams from India. Right. They are the top educators of India you can find. And they're the top educator teams. We are starting this as a vision batch from the June 15th onward. We are starting here. The new subjects are starting. You can find the top educators. And so you can see the target batch for GATE and ESE and the new batches, the top educators of India you can find here. I am also the one of the part of this team you can find. And the vision batch for C. So batch C here, we're starting the regular batches, we're updating. You can see now here the new batches are commencing from the 15th June. These are the GATE and GATE 2022 top rankers from Unacademy. These fellows have cracked it. Now you can able to easily crack it. You can easily able to crack it. These are the ESC 2021 in EC electrical top rankers. And with this Unacademy Plus, you will experience a top educators, doubt solving, study notes, and test series. You will get it. And in addition to that, iconic students will get additional benefits of physical notes, will get one-to-one mentorship and study and study program, live audio interaction with the educators. Right. And these are things here we have. And one more thing is, I'm expecting you here. Everybody try to be regular to the classes and all. So we are planning to discuss each and every problem from basic level to high level. The same timing 7 p.m. we are planning the sessions. So I hope everyone will follow the classes regularly. So चलिए let's start our discussion all of you. चलिए आज हम शुरुआत करेगा. And so ये मेरा here this is the first time I'm coming to the YouTube sessions. ये मेरा पहला YouTube क्लास है. अभी तक मैंने YouTube में नहीं आया. So here the first time I'm coming to the YouTube and all. So here I hope I'm expecting a very good support from you fellows, and be regular to the classes, and definitely you fellows will enjoy the classes. So let's crack it. So let's start our discussions. Now all of you try to respond, and all of you try to comment in your answers for each of problems. Clear? Take the first problem. Which of the following does not have the same units as others? Which of the following does not have the same units as others? Now you can comment your options. Now here this is L by R. Can you tell me the units of L by R? Tell me the units of L by R, which is the seconds. Now this is RC. As we know, RC, which is nothing but time constant now. And what's the units of time constant is a seconds. Next, square root of L by C. Now you tell me now here L by C If I multiply these two here, what I will get, you tell me? So that is L by R. If I multiply this thing with what we can say now RC, then we'll get it as LC. I will get now. Now LC units are what now? Second into second. That means square root of LC. Can you tell me units of square root of LC now here? This is also seconds only. Now what about the square root of 1 by LC? So what about the square root of, this is 1 by LC. And so these units are what we can say now here. Second inverse now, tell me. Second inverse, isn't it? So which will be the odd man out? Which has a different units now here? Option D has a different units now, 1 by seconds. This is the odd man out. Yes. Right. So second inverse. And even we can see now here, this is omega naught, which is given as 1 by square root of LC. The resonant frequency, hope you might know. So what are the units of this omega naught, you tell me? Which is given as radians per second. Na? Omega naught is a resonant frequency. The units are what? Radians per second. Right? Chalo. Next problem. And take the next problem. A capacitor is charged by a constant current of 10 milliamperes. Current source which is turned on for 1 second. Assuming the initially uncharged, determine the power supplied by the source if the capacitor has a value of 1 millifarads. 1 millifarads. Now try this thing, all of you. Yes, try this thing. A capacitor is charged to a constant current source, which is given as, how much you tell me now, I of t, which is given as a 10 milliamps. Is turned on for one second and initially uncharged. Can you tell me the voltage across a capacitor? Can you tell me the voltage across capacitor, which is given as Vc of t, which is given as Vc of 0 plus 1 by C integral of what we can say now here, I of t into dt, right? That is from 0 to t. And so I can get the voltage across the capacitor. They given the initially which is uncharged. That means initial voltage 0 plus 1 capacitance value 1 millifarad. That means 1 by 10 power minus 3 integral of 0 to 2. How much time is given here? 1 second. So that is 10 into 10 power minus 3 milli into dt. So from this I can get my Vc of t. Tell me all of you. So how much the Vc of t here? 10 power, which will get it as 10 into t. Limits 0 to 1. So how much this value? 10 volts. Now tell me all of you. 10 volts. So we got the, this is the current passing through the capacitor and this is the voltage across the capacitor. From this can I get the power? Now tell me. So the power which is given as what we can say here, V into I. So that could be given as the power across the capacitor. How much we can say this is? This is 100 milliwatts. All of you. कौन सा option, tell me? कौन सा option now here? Option B. Done everybody? Chalo. Next problem. Now take this problem. A current waveform as shown is passing through the inductor. Find the voltage across the inductor. They given the current given, now they are asking to find the voltage across the inductor. and the initial value given as a 0, you can see. Initial value to 0 diya, so we need to find the current. Now you tell me now here voltage across the inductor. Tell me now here the voltage across inductor, so which is given as VL of t, which is given as L into di by dt. L into di by dt. Yes. Is the font size I am writing it is comfortable to all of you? Are you facing any difficulty? The font size is clear, you tell me. Right. Now tell me now here the voltage which is given as L into di by dt. Now I need to differentiate this thing here. Look at now here. Look at now here. They given this is the current waveform is given. I need to differentiate now here. Tell me now if I differentiate this step signal, what I will get, to tell me? Little bit dark means you are asking the thick, you are asking to write in thick, isn't it? Now, is it comfortable to all of you? Tell me. Are you able to see it now properly? Tell me, all of you. Okay. Now you can see now here. Now I need to differentiate the inductance value given as a 1 and see the signal what they given now here. The signal which is given as a square wave pulse, rectangular pulse has been given here. You see rectangular pulse they given like this. Now you tell me now here, is this thickness is fine to all of you? This L. So which is given as this is 1 and this is 2 and this is 3 and this is 4 and this is plus 1 and this is minus 1. Right. Now I need to differentiate the signal, isn't it? So anyway, inductance value given as 1 now. So if you multiply 1, no effect. Now you tell me now if I differentiate it now here, as we know, so initially here, the differentiation of step signal will be a impulse signal. Suddenly they rise now here. Initially at t is equal to 0 minus this value here, how much this value, amplitude is 0. At t is equal to 0 plus, this amplitude will be going to high now here 1. That means how much this amplitude, can you tell me here? And this value will rises to a, how much you tell me? Will goes to here. How much this amplitude is 1. Everybody. Next after, now from here to here it is a constant derivative is 0. Constant derivative which is equal to 0. Next after coming to 1, see what happens, you tell me. Now here just before 1 this value is minus 1, just after 1 which is a plus 1. Now tell me it has an impulse. How much the impulse we have? Final minus initial. That means 1. So here, sorry, just a minute. This is minus 1 now. Sorry, this is plus 1 and this is minus 1. So how much this value, tell me, final minus initial, minus 1 minus a minus 1. So this amplitude will goes to how much, you tell me now here? Minus 2. Next again from here to here which will be a 0. Right. Now this is at 2. What happens to tell me here? This value is -1. Here this value is +1. Now tell me now final minus initial. +1 minus or -1. It will become +2 hoga na? Boliye all of you. This is +2. Next again at 3. What happens to tell me? It will goes to -2. Everybody tell me. At 4. Again it will goes to what you tell me now here? +2. All of you boliye. So that means कौन सा option you tell me now here? कौन सा option here? That is option C. Done. Next problem. Now tell me now here. The current waveform they given like this. Now they asking to find the current waveform. They asking to find the voltage across the capacitor. They asking to find. Now they asking to find the voltage across the capacitor. Yes, you tell me now here. How we'll get the voltage across capacitor here? V, which is given as, that is 1 by C integral of I into dt. Isn't it? Tell me. So initial value to 0 diya. If you see carefully, initial value they given. Integration. So that means integration of what you tell me now, this signal I need to do integration. Of course, up to one time period we need to observe. And if we observe carefully the signal, the amplitude here, this value 2, and can you write this current waveform? This is I of t, which is given as what you tell me? I of t from here to here, this is like what you tell me now here? Y is equal to mx curve, yes or no here? Which is equal to plus 2 into t, plus 2t, isn't it? This is from way to way you tell me now here, 0 less than t less than 1. And what about this part of this signal you tell me? Now this signal which is in the form of what we can say here, which is equal to, the slope is -2, isn't it? Slope is -2. I can say -2 plus some c intercept. And here this value, when see this thing, this current expression we can see here I of t, which we can say this as -2t plus c. Now see the coordinates of this point now here, this is 2 comma 0. X coordinate is 2, y coordinate is 0. So at this point can I substitute now here current value 0 when it is now here -2 comma t value, how much you tell me? 2 plus c. So that means how much the c value will get now here? +4 will get. C value will get this as a +4, right? So that means 2t plus 4, I can say. All of you tell me. 2t plus 4. Everybody? Now. So this is the expression for what you tell me from way to way. 1 less than t less than 2. So this what we got the current expressions. Isn't it? Now I need to get what I need to get, you tell me. Now I need to get. So we need to integrate now here. If I see this thing, first I will integrate the signal. After that I will multiply with 2. Capacitance value given as how much you tell me now here? It is 1 by 2. That means into 2 we have to multiply. Now if I integrate now here, the integration of this current I of t into dt. Yes, what I will get to tell me now here, which is equal to 4t square. 4t square by 2. That means which will get this as a 2t square. From way to way, 0 less than and t less than 1. And so after that, from this is minus 2t square. See this thing? Sorry, this is 2 only, na? So this is 2t square by 2. This is 0 less than and t less than 1. So this value means 2 will get cancelled. I can say t square. Simply I can say so t square. Now tell me now here. This is minus t square plus what we can say now here 4t. This is from where to where? 1 less than t less than 2. Isn't it? 1 less than t less than 2. Now, this is the expression here. From this, we can do verification now here. Now, this is the integration of the current waveform. But I need to multiply with C also 1 by C. Then finally, can you tell me the voltage expression kya hoga? Tell me. From this, can you tell me the voltage expression kya hoga? So this is V, which will be given as what we can say here. Multiply with 2, so it will become 2t square. This is from 0 less than t less than 1, and which is equal to minus t square plus 4t. This is for 1 less than and t less than 2. And everybody. Now see this thing here. Now see this thing here. When so verify by using these relations, let us verify from the options which option can satisfy here. Which option can satisfy now here? In between 0 to 1, so at this location we can say at t is equal to 1, t is equal to 1, this is the expression now here. This value voltage is equal to 2, right? Now if I want here at t is equal to 2, tell me here at t is equal to 2 here, so up to here we have seen. Now tell me what happens now here. How much this value? This is minus 4. Yes. So plus 4 into 2, that means which is equal to 8. So which is equal to what you tell me plus 4 now. You see at this location amplitude is like this. Then we have seen up to one time period we have seen, isn't it? After the same thing will repeat again, the same waveform will repeat again. You see this thing here. Yes, this is the periodic waveform we applied, right? We applied the periodic waveform, so then it will be like that. Isn't it? And you can see this waveform, it could be like this, and after this is like this. Next after that it is a periodic here, continuously here like this. It will be repeat forever, isn't it? So kaun sa option tell me? Option C. Kaun sa option tell me? Option C. Everybody? Then chalo, next problem. The next one. When an impulse voltage is applied to the inductor. So what here? So substitute the values here. You see this thing here. At 1, how much the value? When t is equal to 1, how much the voltage? You tell me t is equal to 1. This is the function we have to consider now. T is equal to 1. This is the function I need to consider. Now replace now here. At t is equal to 1. How this variation now here? T is equal to 1. Replace now this function. It is like this. Now if I want at t is equal to 2. Tell me now at t is equal to 2 here now. At t is equal to 2 means at this location. So we need this thing now, tell me. Isn't it? All of you tell me. How you draw these variations now here? You can see at t, see the values now, substitute the values now at these locations. At t, this is the function for from where to where, you tell me now. 0 to 1. 0 to 1 this function, that is 2t square. At t is equal to 0, this value. T is equal to 1, it is a parabolic shape now like this. Parabola like this. Now tell me in between 1 to 2, 1 to 2 we have in this region. So I have to use this function now, tell me minus t square plus 4t. Now at t is equal to 2 exactly at this location. When t is equal to 2, What I did now here, how much this value, tell me, substitute the value of t is equal to in this equation. How much will get? Minus 4 plus 4 into 2 will get plus 4, will get it or not? So that's why here this value is a plus 4. Isn't it? All of you tell me. So that's why option C. So next problem. Take the next problem here. When a unit impulse voltage is applied to the inductor of 1H, the energy supplied by the source is. Right. When an impulse voltage is applied. Yes, impulse signal. As I told, if you remember, whenever they apply the impulse signal, so what we can do here, better you go for the Laplace domain. If I call this current is I, so what we can say now here, this is I of S, which is given as Laplace transform of del of t is a 1, so will be 1 by S. 1 by S. All of you, inductor. So this is Laplace transform of inductor, which is equal to S ohms now here. Right. This is my I of t. So from this we can get I of t. Now tell me inverse Laplace. What is the inverse Laplace? Which will be equal to 1. Yes. Inverse Laplace, which will be equal to 1. Now tell me. U of t is 1. Constant. Yes. What is the Laplace transform of k? Which is equal to k by s. Inverse Laplace of k by s is equal to k constant. I know the current. What is the energy across the inductor? Which is given as of Li square. So that means energy which is given as 1 by 2 L is 1 into I equal to 1. So that means 1 by 2 joule. See. Next one. The final value theorem is used to find final value theorem. Final value theorem is used to find what? Final value theorem, FVT we used to call simply. So which we use generally to find the final value, that is t tends to infinity, which is given as what you tell me now, limit t tends to 0, that is s into x of s, where x of s, it may be a voltage, current, it may be voltage, it may be a current. This is the final value theorem. And we have initial value theorem. So if I want to find the x of 0, which is given as what we can say here, limit here, yes, we can take s tends to 0, limit here, this is s tends to infinity, so this is s into x of s. So the final value theorem, which is used to find what you tell me now here, that is a steady state values. Is that to find the steady state values, we use a final value theorem. And the initial value theorem we use generally to find the initial values, or we can say transient values. Right? So option A. Next. Match the list 1 with the list 2. List 1 with the list 2. I think we already seen this type of problem just now. So we know this is L by R is a seconds. So this means they given this as R by L. What are the units of R by L is a, which we can say second inverse. And so this is, as we know, this is omega naught is a resonant frequency. So this is omega naught, which is given as 1 by square root of LC. And the units here, radians per second. Here the units are radians per second. That means omega naught square, which is equal to 1 by LC. And what are the units for this omega naught square here? Radians per second whole square. Next, RC. What are the units of RC is a seconds. Next, this is square root of L by C. Square root of L by C. The square root of, have you heard about the characteristic impedance, which is given as Z naught, which is given as square root of L by C. So what are the units of this square root of L by C? This is the ohms. It is a characteristic impedance. This is called as a characteristic impedance. I hope all of you might be heard this thing. The characteristic impedance of a transmission line. And what are the units for here? Here these units are ohms. Now match the things now here. कौन सा option satisfy होगा? कौन सा option here? Option A, isn't it? Option A. Actually, if I made the full screen, I'm so here. The font size is not coming properly. Font size is low coming. I think there might be some issue. I think so. I think so. And by next class, I will sort out this thing. Okay, this is the first class now. There are so many things we should learn. So because of this, I'm not able to do it. Okay, when I did a full screen, I don't know what happened now here. The font size is coming very low. Because of that, I'm doing this thing. Right. So next one. The low and medium frequency model of the capacitor is. The low and medium frequency model of capacitor is. Just a comment. Just a comment. You do comment your answers. Okay, so that I can understand you fellows. Okay. Low and medium frequency. Right. Now, this is called the low frequency model. This is the low and medium frequency model of capacitor. Low and medium frequency model. And the low frequency, so this is the capacitance form. And this is the high frequency model. High frequency model of the capacitor. High frequency. At the low frequency, the effect of this inductance value, it is very low. So that's why we can neglect that low frequency, as we know. So that's why we are going. So here at the low frequency, this is the approximations, and this is the high frequency model. Okay. Right. Next. Capacitor acts like for AC signal in steady state. Yes, this is the high frequency model and low frequency model. Yeah, so doing the MS, these are one of the better opportunities. Okay, so then you try for the MTech. Yes, well, Prasad, try for the MTech. If we got a MTech option, it is good. In IITs, if we got admissions, it's a very good. If not, go for the MS. Right. Capacitor acts like per AC signal in steady state. How the capacitor will acts for AC signal? As we know for DC, yes, inductor will behaves like what you tell me now here, short circuit, and capacitor will behave like what you tell me, open circuit. Everybody, inductor behave like a short circuit, capacitor behave like a open circuit. Next, if it is AC signal, what about? For AC signal, how the inductor and capacitor will behave, so tell me how the inductor will behave and how the capacitor will behave. If it is AC signal, inductor and capacitors, and this will behave neither open nor short. Neither open nor short. Neither open nor short. Why this inductor behaving like an open circuit for DC, you tell me? So that means what now? What is the inductance? Reactance of inductor. So as we have discussed AC circuits also, if we remembered, that means impedance, which is given as what we can say here, inductive impedance, which is given as, that is J omega L. J omega L for DC frequency 0 na here. So this will be a 0 ohms. And for capacitor, what happens now here? ZC. So which is given as 1 by J omega C. So this will becomes what now here? Omega value 0. So it will becomes what you tell me, infinite now here. So because of this 0 impedance means what now? Short circuit. Infinite impedance means open circuit. But for AC, you tell me now here, is a frequency is a some finite value now, tell me. Frequency is a non-zero. For DC, frequency is a 0. If it is 0, so tell me now what happens now here? XL, yes, which is non-zero, isn't it? Tell me all of you. So that's why, so this inductor and capacitor will behave its own behavior, isn't it? So that's why it does not behave like an open circuit or short circuit for in case of a AC, right? Neither open nor short circuit. Next. Double energy transients are proposed in the circuit consisting of, double energy means double transients we used to call, that is means second order circuits. Yes, steady state only now, steady state only. Yes, in steady state only will this, it will behave like an open or short circuit. In the steady state, will it behave like an open circuit or short circuit, isn't it? Hmm? So in steady state only it does not. So here in the DC supply only the nature of a inductor capacitor will changes. But whereas in case of AC case, the nature of inductor capacitor does not affect in the AC circuit. It will behave its original behavior if we can see in AC case only. But here because of the frequency at the DC case, inductor and capacitor will loses its original behavior, right? First of all of you do like the session, everybody. All of you do like the session. I'm finding very few likes I'm finding in the sessions. All of you do like the session, everybody, and share to all your friends. No, Sravanti, so yesterday class was cancelled. Yesterday class cancelled. We don't have class because of some technical issue. So the class is cancelled. This is the first class. That is for DC supply, Shashank. So we used to do the short circuit and open circuit. We used to do for DC case, not for AC. Remember? Hmm. Did you remember we have discussed a concept, call it as a sinusoidal steady state. Sinusoidal steady state or the AC steady state. In that means what now here? So at that location, inductor capacitor will be converted to resistance form j omega L 1 by omega C. We have simplified, isn't it? So AC case, it doesn't behave. Next, double energy transients. When we have double energy transients. So that is for what you tell me. So for that we need to have two memory elements are required. Two memory elements are required, right? So what are the elements you tell me now here? Both inductors and capacitors both must be present. Then we have a double energy transient. That means that type of circuit is called as a second order circuit. So कौन सा option you tell me? कौन सा option you tell me now here? Option D. All of you. Yes, both inductor and capacitor must be present. Next, the transient current in a loss-free LC circuit, when excited from an AC source is dash sine wave. Dash sine wave. You tell me now here. They mention this is the loss-free LC circuit. That means there is no losses. No loss. That means there is no dissipation. There is no dissipation. That means R is equal to 0. Now tell me. Resistance equal to 0. Yes. That means as we know, remember this is zeta, damping coefficient, which is given as what you tell me now here, R into, that is square root of L by C. As this R value 0, then means what happens, you tell me? R value 0, then what happens now here? Zeta value will become 0. If the zeta value becomes 0, then how the response you can say here? Then the response is undamped response will get. Then we'll get the response is undamped response. Isn't it? Tell me. Which is a undamped sine wave we can get. Oscillatory. Yes. Yeah, so here double energies are because of inductors and capacitors. Whether the resistance is present or not, कोई फर्क नहीं है here. Inductors, capacitors must be present. Yes, for all of you do like the session, everybody. All of you do like the sessions. Next, the transient current in a series RLC circuit is oscillatory. Oscillations का मतलब क्या है? Oscillations का मतलब क्या है? We should have, these are the oscillations. So we have, these are the oscillations we have. These are the oscillations we have ना. What is the oscillations का मतलब क्या है? Tell me here. Here zeta, that must be what we can say here. How much it is? Less than 1. That is a underdamped response. Underdamped response. Right. In that cases, zeta will be less than 1. What is the zeta value? Tell me now here. Which is equal to, this is R. So what is the zeta in this case of a series RLC circuit? You tell me. Yes, which will be given as zeta, which is given as, that is r by 2 into square root of c by L. So that means what we can say now here, that is r by 2 into square root of c by L. This must be less than 1. So that means r must be less than what we can say here, 2 into square root of L by c. Isn't it? All of you tell me. So the option C. Yes. Here this we have written a parallel case zeta we have written. If you observe parallel case, now here let us write a series case zeta. So which is equal to r by 2 into square root of c by L. Okay. Next. A DC voltage source is connected across a series RLC circuit. Under steady state conditions, the applied DC voltage drops entirely across. Where the entire DC voltage will be available? Where the entire DC voltage is available, you tell me? A DC voltage. Yes, a resistor, inductor, and capacitors are connected in series. Now they given some DC supply. So the DC supply is given. So this means let us say this is something Vs. Tell me now L and C. So tell me now here for DC supply, how the inductor will behave, so tell me. For DC case, so how the inductor will behave like a short circuit and capacitor will behave like an open circuit. So this means how much the current passing through the loop, you tell me. Current equal to 0. That means what is the voltage across a resistor, you tell me? 0. And what is the voltage across inductor, since it is short circuited, which is 0. But here whatever the voltage across the capacitor, you see voltage across a capacitor here, which is equal to complete voltage here by applying a KVL. This is my VC here, open circuit. Complete voltage will accumulate at the capacitor only now. So that is Vs. So that means the complete voltage across the capacitor. Next, consider the DC voltage source connected to a. So listen here, we are planning to discuss the problems from the very basic level to high level. Don't think this as we are solving a very simple problems. Basic problems to high levels we are doing, so that you will be comfortable to solve any problems. Totally, I told you now, nearly we are going to solve the 400 problems we are going to solve on this transient topic only. Okay, right. Let's continue now here. A DC voltage source is connected to a series RC circuit. When the steady state reaches, the ratio of the energy stored in the capacitor to the total voltage. Now tell me now DC voltage which is connected, completed, all of you tell me. Very good. Series RC circuit they have connected. This is my R and this is my C. And here I can consider that this connection which is done at t is equal to 0, the switch has been closed. Isn't it? By doing the DC now here. At t is equal to 0, switch has been closed. Now, I can say here, initially what we can say now, VC of 0 minus, which is equal to 0, and VC of infinite, which is equal to V, right? So here, and as we know here, VC of 0 plus, which is also same as VC of 0 minus only now, which is equal to V. Now here, हमारा तीसरा song स्मरण है ना सभी को? I hope all of you remember our third song, which is equal to what, you tell me? That is final value तीसरा song याद है ना? final value plus initial value minus final value into e power minus t by tau. अब तीसरा सम याद है ना सभी को, बोलिए. So now from this what we can say now here, my VC of t, voltage across capacitor, we are doing here. Final value, so this is V, initial value 0, which is equal to minus V into e power minus t by tau. Tau is equal to RC. Tau equal to RC. Now you can tell me now here. So from this I can get the current now here, IC of t. I equal to C into dV by dt. C into dV by dt. So here by differentiating this thing here, what I will get, you tell me, which is equal to minus C into V, that is plus by RC into e power minus t by RC, right? So from this what we can say now here, IC of t, which is given as V by R into e power minus t by RC. This is my current. This is the current through my capacitor, right? As we know here, what is the energy across the capacitor, which is given as what we can say, that is simply of CV square, we know na? Energy across capacitor is of CV square. Now I need to find the energy supplied by the source. Now this current which we got it as a IC. Now can I get the energy given by the supply? Energy given by the supply, which is given as what we can say, until the steady state has been reached. Now tell me, until the steady state has been reached. So that means what we can write now, energy which is equal to, which is P of t into dt. Can you tell me the power first of all here? What is the power? You tell me now, P of t, which is given as voltage into current. If we multiply this voltage into current, so tell me now what I will get, you tell me if we multiply. So this is P of t. I can say this as, this is my voltage, sorry, this is a capacitor voltage, right? And the supply voltage into current. So if we multiply this thing, what we'll get now here, this is V square by R into e power minus t by RC tau. So from this I can get my energy until the steady state has been reached. And steady state means 0 to infinity. So that means energy supplied by the source, which is given as source energy, which is given as, that is from 0 to infinity, which will get V square by R into e power minus t by RC into dt. So which is equal to V square by R integration of e power minus t by RC by minus 1 by RC, limits 0 to infinity. So from this I can get my energy, now tell me, which is equal to V square by RC into RC. V square by R only, sorry, this is R. This is into RC. So that means what will get, CV square, which is equal to CV square. So that means what we can say, what they asked now here, the energy stored in the capacitor to the energy is supplied by the source. How much now energy of a capacitor by energy given by the source now here. So how much this value, which is equal to of CV square by what we can say now here, CV square is equal to 1 by 2, right? So what will be the option, you tell me now? Option B. Everybody pick the option. Take the option, everybody. And yes, understood the problem, how we need to solve it now here. So this is the first transient problem we have started, right? Okay, so here fine. So here And so this is a first class. So here, if you are facing any difficulty, we are really sorry. And soon we'll sort out the problems and all. So I will try to make the YouTube session the best possible manner. Okay, I'll rectify all the problems whatever we are facing, the PPT, the font size, everything. And I hope in the next class you don't face these problems. Okay, and the next class I think we have on 14th we have a YouTube class, next class. First of all of you do like the sessions and all, do like the sessions, and already schedule the session, you can see. And one more thing is, and tomorrow we have a special class at the same time. In the Unacademy app, we have a special class at 9, at same 7 p.m. At 7 p.m. we have a session. The 7 p.m. session, same timings, we have a class. Alternated YouTube class and special class. 7 p.m. session, we are doing the network theorems problems we are solving. Network theorem DPP, we are going to solve it. Okay, fine. So here, I hope all of you enjoyed the sessions and we'll meet in the next class. Okay then, see you, bye-bye. Good night.